Hi everyone, welcome to a closer look at built-in macOS security tools. My name is Stuart Aschenbrenner. I work for Jamf, more specifically Jamf Protect, on the detections team. My job is to find new ways to catch malware, so glad you could tune in today. A quick disclaimer of my own, this is, as you saw, a pre-recorded presentation, and with macOS and especially macOS security changing so constantly, I thought it was important to note that all the tools I'll be talking about are taken at the time of this recording, and if they're updated, I will update you in the chat. So let's get started. I'm sure you're all well familiar with this very popular advertising campaign that ran from 2006 to 2009, the I'm a Mac, I'm a PC campaign. And the big idea behind it is that PCs get viruses and Macs don't. However, over the last dozen years, it's been debunked 100 times over that indeed Macs do get viruses or malware or adware. And some of the tools we're going to talk about today were actually introduced around the time of this campaign. So either between 06 and 09, or right before, which is one as well. So let's kind of dive into some of these tools. The primary ones we're going to talk about are going to be the first three I mentioned here, but we'll touch on all these as well. So I also want to note that we're not going to be talking about ESF, the Endpoint Security Framework. It is a framework and not necessarily a tool, but there's another talk you can check out for more information on that. So some of the tools we're going to talk about, first up is going to be Gatekeeper. We're also going to talk about XProtect. I'm sure you've heard of it. MRT, or the malware removal tool. We're also going to briefly touch on a few others, including notarization, file quarantine, and last but not least, TCC, or the Transparency, Consent, and Control mechanism. So I like to think of all of these different tools, similar to this slide here of a polar bear in a snowstorm, where they're always kind of hiding behind the scenes, not necessarily visible to the end user, but they are indeed doing work. And you can use them all in tandem just by themselves. You don't have to use a security solution on top of it. However, it's definitely the recommended method, where if you have something like Jamf Protect, it can run perfectly well with the built-in security tools and work on top of those as well. So what are these tools? We're going to start with TCC and then dive into the others. But TCC fundamentally looks like this. You open up an application, say it's this one called QLab, and you click the microphone button to use your microphone, and Mac prompts you to allow access to the microphone. Same with things like the camera. And this is a design by Apple to make sure that software is not accessing different parts of the hardware. Now, to the user, if you go to change these permissions, it might look a little more like this in your system preferences, where here we have a few apps that have requested full disk access. You can see I've agreed to allow 3 of them from Objective-C to use it, but not yet the top one, suspicious package. And all these can actually be enforced via MDM, except for a few, including camera, mic, and screen sharing. And this is more like inherent privacy to the end user. And you can see that here, where I actually did allow the camera access to QLab, but I haven't yet to Google Chrome. So TCC at its core is a couple of databases, one in the root library and one in the user library. We're just going to go to the root library here and open up this database. I like to do a lot of work just from the command line. We run the tables. We can actually just grab all the items from that access table and see what we're looking at. So this is a ton of information, so let's just grab what we really care about, which is going to be the client, auth reason, auth value, and the service from this access table. This will make it a little easier to understand. We have 4 columns here. So let's grab one of these items. But before we do, let's just grab all the items that have requested full disk access, which is the service system policy, all files. So here we have quite a few options. So let's just pick one. Let's do the ESF Playground by the Mitten Mac. And just to make it a little easier to read, let's go ahead and drop this into a text editor. And we'll actually be able to kind of step through this and see what these different things are. So first up, we have the client requesting the permission. That's his first one. Next up, we have 2 enums. This first one is going to be the TCC auth reason. And if we kind of look at what all these different numbers could represent, ours is number 4, which is system set. We have other things like user consent, user set, or MDM policy. Following that, we have the auth value, which ours in this case is the number 2. So let's look at what those are. So we allowed this application, we can also deny it or limit it, or there's also an unknown option there as well. Last but definitely not least is the service. And as I mentioned, this is going to be full disk access, this KTCC service system policy all files, but there's a ton of different options here. And we can open that up. We can see maybe the most critical ones, which would be like sharing, iCloud, or location, things like screen capture or access to the downloads folder, and then just different services, whether it be your calendar, reminders, or Siri. Okay, so one of the fun things I like about TCC, and you don't have to do this, you could do this all from your system preferences, but we can actually reset all of the approved applications from the command line. So if we get the code signing information and grab the bundle ID, we can actually just run sudo tcc util and then run reset all and specify the bundle ID, and it'll actually reset all approved statuses for that specific bundle, which in our case was that QLab bundle. So that's a brief mention on TCC, but really the three main tools, in my opinion, or three main components form to this check, block, and remediate. So we're going to step through each of these separately, but first we're going to start with check. And these actually map over quite well to three tools on macOS, which are Gatekeeper, XProtect, and the malware removal tool. So we'll talk about Gatekeeper, which is enforced by sys policy D. However, before we get into Gatekeeper, which gets called when an app is clicked the first time, it's important to note what file quarantine is. And file quarantine is really the step before Gatekeeper. So this is when an app is downloaded and clicked for the first time. So to show you what it looks like, I know it can be kind of confusing, but let's take this application that we just downloaded from the internet and go ahead and try to open it. And this is what file quarantine is really. It's going to say, hey, this app was downloaded from the internet. Are you sure you want to open it? And at that point, you have the choice to say, yes, I want to open it or not. And this was introduced back in OS X 10.5 Tiger, which you could buy the CD for $129.99. And the whole reason is not to allow newly downloaded files to open without the user's explicit permission. And Gatekeeper's built on top of this, and they work in tandem. And I'll try to keep them both separated. It might be impossible, but Gatekeeper's really a front end for the system policy control binary here. And you can run this from the command line to check the status of an application to see if it's approved by Gatekeeper or not. So let's take a look at one of those. So here it is running from the command line. We want to specify that we want it verbose, run a couple of flags, and this is working alongside file quarantine. And what Gatekeeper is doing here is seeing if file quarantine has set any flags on this specific application. Right now, we see that the Gatekeeper information, or excuse me, the signing information was rejected. There's no good signature, so Gatekeeper is actually going to block this application. But what does it look like if Gatekeeper is approved to open an application? So let's find one whose code signing information is valid, and we'll go ahead and run this command again, just a little abbreviated. And here we see that this one is signed and notarized by Jaron Bradley. So this one will be allowed to open. So Gatekeeper is kind of picky, and it applies to things being executed, not necessarily open with a program. So if I were to download a photo or a GIF from the internet and open it with preview, Gatekeeper wouldn't check it. However, if we have a script that we're not executing from the command line and instead are double clicking it, we'll actually see that it gets checked. So we have this application, we spin up just a quick Python server and download it, and it's going to say it can't be opened because it's from an identified developer, which is true. This script has not been signed. And so if Gatekeeper blocks something, it'll throw you this alert from the core services UI agent. And this doesn't, of course, apply just to scripts. It applies to just your general DMG that you'll download. So if I go ahead and download Google Chrome and open the DMG and mount it and go ahead and try to launch Google Chrome for the first time, file quarantine is going to complain and say, hey, are you sure you want to open this? And the good part about this is between file quarantine and Gatekeeper, file quarantine is going to check this, say you can open it. If I did say open, then file quarantine would basically tell Gatekeeper that this is okay to open. So what does this look like under the hood? I know it's a lot, but if we check the extended attributes of Chrome before we try to open it, we just run the xadder command and we see that the com.apple.quarantine extended attribute is assigned to it. So if we go ahead and print out the contents of it specifically, we can get back some information here and figure out what's going on. So if we look on the far left, we see the numbers 0083. And if you see 0083 or even 0081, that means don't run this yet and make sure Gatekeeper checks it before opening it. So once Gatekeeper has checked it and opened it for the first time, this extended attribute will eventually change. So this is the example of an app that's been checked already. We see Lulu here, an app from Objective-C, and we see 01C3 instead of that 0081. So this one's been approved. So it takes all this information here and stores it in a SQLite database. But what is all these different pieces? So first up, as I mentioned, we have this flag saying to run or to check. We have a date or timestamp. The agent it's associated with, in this case it was Safari, and a unique identifier or a UUID here. So at this point, the file quarantine is going to save this information into the quarantine database. So another SQLite database. Apple loves their SQLite. So we can go ahead and pop this open. It's in the user library and preferences and a few steps into it, but we can actually pop this database open and take a look at the internal components and see what's going on, kind of in the same fashion we just did. So if we look at the tables, we see there's just one. So if we go ahead and let's just grab 10 items because it's going to be a little easier to see on the screen and not blow up my terminal. We can actually look at what metadata is being collected here. So if we grab these 10, we see things like my name, Stuart, we see some UUIDs, it appears, and some com.apples. But let's just grab the most recent. So let's just grab one item here and do what we just did and pull this out and drop it into something so we can break it apart and look at the different columns here. So if we throw this into text editor, we have 11 different columns to sort through. First up, as you saw, I kept the query here just for reference sake. Next up, we have a UUID, and this is mapped to the database. On the left, you have what it's called in the database, and on the right, what it's kind of, I would say, more easily to call it. So we have the LS quarantine event identifier, which is just a UUID. We have a timestamp, which is in Mac absolute time, which is different than epoch time. It's actually this CF absolute time here, which is a point in time relative to January 1st, 2001 at midnight, as opposed to 1970, which is epoch time. They jump around quite a bit with their timestamps. All right, so there's a timestamp. Next up, this happened to be empty on this specific item, but this would be where the bundle name is. You also have things like the app name or the agent name, the data URL string. If it comes in an email, this is where you'd have the email sender name as well as the email sender address. Following that is the type number, and this is another enum as we saw earlier. And we can actually pull this up and look at the different content. So ours is 0, which means a web download. We also have things like IM attachment or calendar attachment. All right, next up, this was empty in all of mine as well as in line 12, but I'm speculating based on what the column name was as origin title. This is the title or name of the origin. Following that, we have the origin URL string or origin URL, and lastly, the origin alias. All right, so with all this information, file quarantine says, go ahead, Gatekeeper, run this or not. So when Gatekeeper runs, really, what is it doing? Well, first, it reaches out and grabs the team ID. And again, it has to be double-clicked. It can't be run from the command line like a script. They won't get checked. So go and grab the team ID of this application or executable. Let's just say, for the sake of this presentation, that is this team ID. And we want to decide if we want to go ahead and approve it or deny it. Or if we want to see if Gatekeeper will do that, not me personally. So what Gatekeeper does is it looks at a few different databases, and one of them is actually located in this XProtect bundle. And if we list out the files, we see something called GKDB, and this is another SQLite database. And what Gatekeeper is doing is it's running that team ID against this database. So if we go ahead and check the different tables in here, we have one called settings, but one called block caches and block teams. So Gatekeeper is taking our team ID and looking to see if it is part of that block teams list. So I'm not going to run like a very fancy SQLite command where we're checking on mine specifically, but we can see this whole long list of different team IDs. And actually, there is 132 of them combined in this database. And there's two other places that Gatekeeper looks. One is in a GK opaque bundle and one is in a GKE bundle. Those are both in VARDB. And those are allowed or used for allow listing. So Gatekeeper checks those to see if different things are allowed, where this one's used for block listing to see if we want to block a specific team ID. So ours was not in there, so that's great. But now Gatekeeper checks to see if our software is notarized. Now you need internet access for this, but if you go ahead and double click it, during the development process, Gatekeeper does a check to see if, during the developer process, you actually have to get notarization on your app. Basically, get different things like a secure timestamp, and Gatekeeper then checks to see if your application has been notarized. And when you're done developing your application, you actually have to take that notarization and basically staple it to your application when you distribute it. So luckily, this piece of software that we're hypothetically running has been notarized with this team ID, and the team ID was not found in the block database. So this one passes the Gatekeeper check. Now, this is a lot going on under the hood. So what does this look like to the end user? Well, Gatekeeper is part of the system preferences in security and privacy, but Gatekeeper can be overridden, which is a purposeful design by Apple. So down here at the bottom of this, we see that we have allow apps downloaded from, and we can choose either the App Store or App Store and identified developers, but that doesn't mean we can't download something from an unidentified developer. So let's go ahead and try that and see what happens. So we're going to get this program called MacOS, which I run all the time at work. So I know it's a good program. So we're going to go ahead, and if we look back in the system preferences, we see that nothing has changed down on that bottom half. So let's go ahead and try opening this application from an unidentified developer. So if we try to open it, we get a pop-up from the Core Services UI agent that says you can either eject it or cancel. So we don't want to eject it. We actually want to try to install it. So if we hit cancel, we see in our system preferences that we have the option to open it anyways, which gives us another pop-up, which then we can say, go ahead and open this application. It's good. And that'll go ahead and open our application. Now, this is kind of clunky and a lot of work to do for just opening an app. So we're going to show you a shortcut, and I'm even taking the longer way around this shortcut. So if you download an application for the first time, we're just kind of resetting the scenario, and we go ahead and mount it. Instead of trying to open it and going into system preferences, instead of doing all this, we can actually just right-click the application and hit open. And this will actually jump us straight to this pop-up where we can hit open and go ahead and launch our application. Now, unfortunately, because Apple has designed this idea to override Gatekeeper, some malware has began to catch on. So very common malware called Schlayer. Say you're online and you see that you need to update your Flash player, which is at end of life, but say I got tricked into doing it. And I downloaded what I believed was a Flash player update and I open it. The Schlayer malware, which is actually what this is, a disguised Flash player update, will actually show you how to override Gatekeeper. So by right-clicking on the icon and hitting open, I'm actually overriding Gatekeeper in this social engineering technique by the malware. So that's Gatekeeper in a nutshell, but since we're actually sitting here in this XProtect bundle where this Gatekeeper database is located, let's take a deeper dive into XProtect itself. And XProtect is our block section of our check block remediate. So XProtect kind of at its core is really a static list of YAR rules that were released in November of 2017. They all have obfuscated names, so you can't really tell what malware it's looking for, but we'll come back to that specific file. So XProtect gets called when a new access event occurred. And notice that's not necessarily execution. So if I were to find this binary, instead of double clicking it and running it, I just open it, whether it's in a text editor or if it's a script that's supposed to be caught by Gatekeeper. I'm just going to copy this to my desktop, and instead of trying to execute it, I'm just going to open it with a program called Hexfiend, which basically reads the bytes of a file. So we're just going to access this file and not run it. And we will see that XProtect actually says, this will damage your computer, you should move it to the trash. So XProtect still detects it on an access event. So XProtect is located down a long line of folders, and we can step into this core services folder, which is a few levels up from that XProtect YAR rule. We see that there's an XProtect bundle, an XProtect app. So we're in that XProtect bundle. We'll come back to the app, and let's talk about the other files that are sitting down there with that GK database. And we'll skip over that since we mentioned it already. But let's start with the legacy entitlement allow list. So this was introduced back in February of 2020 at the same time as XProtect version 2114 and MRT 1.55. And it's this array of CD hashes. And we can't say for 100% certainty what this file is used for, but we can speculate based on the name that it's an allow list of MacOS that need some type of legacy entitlement. So alongside that is the XProtect meta plist, and this will block things like malicious plugins and Safari extensions. And each of these entries has a bundle ID and a developer ID associated with it that it's blocking. And if we scroll farther down that file, we actually see that it also looks for things like outdated Java or outdated Adobe Flash Player. We come then to the XProtect plist. This has entries in it like description, launch services, and matches. So the description is just the malware name here at the top. We also have in launch services, this is what URI type it should trigger on via the ls item content type. And this would be something like an application bundle or a Word doc or a PKG file. And then we have matches, which is an array of dictionary objects, which is how to detect it via that NSURL type identifier key. And if detected, it'll throw you an alert similar to this. This will damage your computer. You should move it to the trash. And last but not least was that YARA file we talked about. So you'll get an alert from the core services UI agent. And if XProtect detects on something, it will actually write a diagnostic report into the user library logs into an XProtect diagnostic file, which you can see here. So there's quite a few different options here, whether it's the bundle identifier, the URL, a timestamp, or even what action the user took if they moved it to the trash or canceled. And of course, the signature detected on. And this is a very consistent way of noticing if XProtect triggers, which is a new file in this diagnostic file. So if detected, you'll see this alert. And if XProtect is actually able to catch the malware name from that YARA file, it'll actually include it here in this alert. So it'll tell you this will damage your computer because it contains this type of malware. All right, so that's it for the XProtect bundle. And before looking at the XProtect app, let's look at one other thing that comes into play, which is the remediate portion, which is the malware removal tool, MRT. Now, the difference between XProtect and MRT is XProtect blocks via YARA, static files, and MRT is looking for specific file paths. So it'll scan your system and look for all these different file paths and is laid out in that kind of common application bundle style with the contents macOS and a couple binaries. And MRT actually seems to be retiring. Right now, it remediates close to 100 different malware samples. And it has these two binaries, one called MRT and one called MRT helper. And MRT can actually run from the command line as an agent or a daemon. And it's really important to note that users don't have to run it this way. This is more, I found this really interesting that you could run MRT from the command line. But MRT just runs silently, like when a user logs in or when the machine reboots. So if we go ahead and run the malware removal tool as the agent, it'll actually scan our system. For some reason, it doesn't find an applications folder, which I do have, but it'll finish its run, say it doesn't find anything. And it can run as the daemon as well. So if we actually load MRT into a disassembler, we can actually see it's looking for some different files because not finding anything isn't too exciting. So if we look through this in a disassembler, we actually see that there's this osx.atg2.a malware that it's looking for. And within that, it's actually looking for 4 different file paths. So a couple update plists, and a couple of files in a shared folder. So let's try to see if we can create those and get MRT to pick up on them. So if we just put these files on the system, we aren't going to load the plists. We're literally just going to write blank files to these paths. So for the sake of brevity, let's kind of skip over some of that. So we have all of our files. And now let's run MRT again to see if it'll actually pick up on those. So I'm just going to run it as an agent. And again, you don't have to do this from the command line. It'll do it by itself. But we did find that ATG2 malware, and it did fail to unload the plists, which makes sense because we didn't load them in the first place. But then it subsequently deleted all 4 of those files that we created. So that's MRT in a nutshell, but MRT actually seems to be folding into a new product, as we said, it's retiring, called XProtect Remediator. And this is where we step back and see that XProtect.app. So similar to MRT, this is also in that similar contents macOS file structure, except within the macOS folder, we actually have 12 different binaries in here, as opposed to just the 2 MRT binaries in the MRT app. And we'll run through these really quick. So first up, we have one. All these are prepended with XProtect Remediator, but first up is WaterNet, the WaterNet malware, and AdLoad, a very common malware. DubRobber, which is the same as XSet or XCSet or XCSset, whatever you call it, which is a very sophisticated backdoor malware that infected Xcode using 0 days. A detection for EICAR, which is a benign file you can put on your system to test security solutions. We've one for Genio, a very common malware, which has been known to be packaged with potentially unwanted programs or pups. Popular cleaning apps, especially things with like Keeper or Cleaner in their names. We have one for the detection of Greenacre, one called MRT-v3, which seems to be the catch-all for what's not in here. It's about the same size as the MRT binary in the MRT app. So I believe this is that catch-all, and this is kind of what MRT is folding into. We also have a binary for pirate, sheep swap, which is probably my favorite piece of malware name ever, toy drop, trophy, and of course just an XProtect binary by itself. So what used to be Gatekeeper, XProtect, and the malware removal tool pre-macOS 12.3 appears to be looking more like this moving forward, which is Gatekeeper, XProtect, and XProtect Remediator. All right, so that was a lot of information, so let's quickly review. So TCC, the Transparency, Consent, and Control, is designed to help restrict apps access to different pieces of your hardware or software. File Quarantine will check with you on a newly downloaded file that's double-clicked from the internet for the first time, and will give you a prompt if you want to allow it or not. Gatekeeper, similar if you click on an app for the first time, or an executable. Again, it doesn't apply to things being run from the command line. XProtect, which blocks malware and gives you the option to either cancel or move it to the trash. And then MRT, or the malware removal tool, which looks for specific file paths and then removes them, and goes hand in hand with what's now XProtect Remediator. And this doesn't give you any alerts. So really quick, I want to give a couple references. Even before I started working at Jamf, I did a lot of reading from Howard Oakley and Phil Stokes. Howard Oakley of the Eclectic Light Company and Phil Stokes at SentinelOne, on their writings on the internal macOS security. Great content by them. Of course, Jonathan Levin's OS Internals book, and then the Jamf Protect Detections team of Matt Benyo, Jaron Bradley, and Firdaus Seljuki. And on that note, there's a couple sessions I highly recommend checking out. The first one by Jaron and Matt, called Leveraging Apple ESF for Behavioral Detections, if you want to dive more into the endpoint security framework. A deep dive into a specific Safari vulnerability that was actually discovered and disclosed by Firdaus Seljuki. And one called Anatomy of a Mac Attack. This one's also by Matt and Jaron. So make sure you check all those out. And thank you very much for coming to this session. And I hope you have a great day, and thank you for listening.